Imagine a monster sitting in the center of a distant galaxy, a cosmic drain so powerful that not even light can escape its grasp. We've known about black holes for decades, but our textbooks told us they were slow, patient eaters. They were supposed to grow gradually, consuming the gas and stars around them at a rate dictated by the strict laws of physics. But astronomers just found a rule breaker. Deep in the ancient reaches of the universe, there is a supermassive black hole that isn't just eating, it's feasting. It is growing 7 times faster than the absolute theoretical limit of physics, a speed that should, by all accounts, be impossible. It is as if this object is ignoring the very fabric of space and time to pack on mass at a rate that threatens to rewrite everything we know about how galaxies form. NASA and the world's most powerful observatories are scrambling to explain it. But right now, the data says one thing. This black hole is doing something it shouldn't be able to do, and nobody knows why. Today, we are diving into the discovery of the hypergrowth black hole, the mystery of the Eddington limit, and the terrifying possibility that our understanding of gravity and light is fundamentally incomplete. To grasp why a black hole growing 7 times too fast is such a big deal, we first need to understand the speed limit of the universe. In astrophysics, this is known as the Eddington limit. Think of a black hole like a cosmic vacuum cleaner. As it pulls in gas and dust, that material doesn't just fall straight in. It swirls around the black hole in a glowing, hot disk called an accretion disk. This material gets so hot and moves so fast that it starts to glow with incredible brightness, emitting massive amounts of radiation. This radiation creates outward pressure. The wind is so strong it pushes you back. The Eddington limit is the perfect balance where the gravity pulling stuff in is exactly canceled out by the light pressure pushing stuff away. If a black hole tries to eat too much, the radiation should blow its food away into space, forcing it to stop growing. But the black hole we just discovered, LID 20488, is essentially running through a hurricane as if it weren't there. It's consuming matter at 7 times the limit, which means either our math is wrong or this black hole has found a way to cheat the laws of physics. This discovery came from the combined power of the James Webb Space Telescope and the Chandra X Ray Observatory. When astronomers looked at this specific region of the early universe, they expected to find a typical young galaxy. Instead, they found a beacon of X-rays so intense it shouldn't exist. By measuring the light from this object, they were able to calculate its mass and compare it to its brightness. The numbers didn't make sense. Usually a black hole of this mass would take billions of years to reach its current size. But we are seeing this object as it was just a few 100 million years after the Big Bang. It's like finding a fully grown blue whale in a goldfish bowl that was filled with water only 10 minutes ago. There simply hasn't been enough time for it to grow this large following the standard Eddington rules. Why does this matter? Because supermassive black holes are the anchors of galaxies. They aren't just rogue entities. They are the heart of the structure of the universe. If black holes can grow this fast, it means galaxies can form much earlier and much more violently than we ever imagined. This suggests a Wild West era of the early universe where the laws of nature were being stretched to their breaking point. Researchers are now wondering if black holes in the early universe had a different set of properties. Perhaps the gas in the early cosmos was denser, or perhaps gravity functioned with a different strength in those high-energy environments. We are forced to ask, is this an isolated freak of nature? Or is this the smoking gun that our standard model of cosmology is missing a massive piece of the puzzle? One theory being whispered in the corridors of NASA is the idea of super-Eddington accretion. This is the cosmic equivalent of a person being able to swallow a whole Thanksgiving dinner in 1 second without choking. Some scientists think that if the gas falling into a black hole is arranged in a very specific way, perhaps in a thick, donut-shaped cloud instead of a flat disk, the radiation might get trapped inside the cloud. This would allow the gravity to keep pulling stuff in without the light pressure standing in the way. It's a brilliant theoretical workaround, but we've never seen it on this scale. If LEDT 20488 is using this method, it means black holes are much more clever at manipulating their environment than we gave them credit for. It turns them from passive eaters into active predators that can bypass the speed limits of the universe. But the mystery doesn't stop with the growth rate. It's also about the seed problem. If you have a black hole that is already millions of times the mass of the Sun just shortly after the Big Bang, how did it start? Usually black holes are born from the collapse of a single star, but a star-sized black hole, even growing 7 times faster than normal, still wouldn't have enough time to become a supermassive giant in such a short window. This leads to the direct collapse theory. Imagine a giant cloud of gas, thousands of times bigger than our sun, that doesn't form stars at all. Instead, the whole cloud collapses all at once into a jumbo black hole seed. This would give the black hole a massive head start. The discovery of LID 20488 is the strongest evidence yet that these jumbo seeds are real. We are looking at a cosmic shortcut that skipped the star-building process entirely to create a monster from day one. The sheer energy being released by this growth is staggering. This black hole is shining with the light of trillions of suns. The X-rays coming from its core are so powerful they are literally vibrating the gas in the surrounding galaxy. Astronomers believe that this hyper-growth phase is so intense that it might eventually stop the black hole from growing by blowing away all the gas in its entire host galaxy. This creates a fascinating paradox. The black hole grows so fast that it effectively removes its own food supply. This could explain why we don't see black holes growing this fast in the modern, local universe. The early universe was a buffet, and this black hole was the first to the table, eating so fast it cleared the room for everyone else. Let's talk about the dark matter connection. We know that dark matter makes up about 85% of the matter in the universe, but we can't see it. However, we can see its gravity. Some researchers are proposing that LID 20488 might be sitting in a dark matter halo that is exceptionally dense. This extra gravity could be acting like a funnel, forcing gas into the black hole at a rate that overrides the light pressure. If this is true, it means black holes aren't just eating normal matter. They are being force-fed by the invisible structures of the universe. This would link the growth of the largest objects in the cosmos directly to the mysterious dark matter that holds everything together. It turns the black hole into a visible marker for the invisible hand of dark matter. The James Webb Telescope has been a game-changer for this research because it can peer through the thick, obscuring dust of the early universe. Before Webb, these hypergrowth black holes were hidden from us. They were cloaked in the shadows of the past. Now that we can see them, we are realizing that the early universe was much more crowded with monsters than we anticipated. For a long time, we thought supermassive black holes were rare, but James Webb is finding them everywhere, and many of them are like LID 20488, growing way too fast. This suggests that the standard model of how black holes grow isn't just slightly off. It might be fundamentally wrong for the first billion years of time. There is also the heavy metal problem. In astronomy, metals are any elements heavier than hydrogen or helium. These are created inside stars. But LID 20488 is found in a region of space that already seems to have a lot of these elements. This means that before this black hole reached its current size, this pushes the timeline of the first stars even further back. We are looking at a universe that hit the ground running, forming stars, black holes, and heavy elements at a pace that feels like a time-lapse video. The hypergrowth black hole is just one part of a larger story of a universe that was in a much bigger hurry than we thought. The discovery has also reinvigorated the debate over modified gravity. Some physicists suggest that perhaps the reason we see things like this black hole growing too fast is that our understanding of gravity is local. Maybe gravity behaves differently across vast cosmic distances or in environments with extreme density. If gravity was slightly stronger in the early universe, the Eddington limit would be higher, allowing black holes to eat more without their food being blown away. It's a radical idea that would require us to overhaul Einstein's general relativity. But when the data contradicts the theory, everything must stay on the table. LID 20488 might be the first clue toward a new physics that bridges the gap between the small-scale quantum world and the large-scale cosmic world. Think about the sheer scale of the LID 20488 system. The accretion disk around this black hole, the glowing swirl of matter, is likely larger than our entire solar system. The gravity is so intense that time itself would slow down as you approached. To an outside observer, you would appear to freeze in place, while to you, the rest of the universe would age in a matter of seconds. And yet this massive, complex, time-bending machine formed in just a few 100 million years. It challenges our concept of cosmic time. It suggests that the history of the universe isn't a slow, steady progression, but a series of explosive, high-speed events that we are only just beginning to map. How do astronomers even measure something that is billions of light years away? They use a technique called spectroscopy. By breaking the light from the black hole into a rainbow, they can look for specific fingerprints of elements like carbon and oxygen. The width of these lines in the spectrum tells them how fast the gas is swirling around the black hole. From that speed, they can calculate the gravity needed to hold that gas in place, which gives them the mass. Then, they look at the total brightness to see how much energy is being released. When they did this for LED 20488, the light-to-mass ratio was off the charts. It was emitting far more energy than its mass should allow under the Eddington limit. This is the hard evidence that can't be explained away as a simple observation error. The black hole is objectively too bright for its size. Some scientists think these fields might be acting like guidelines for the falling gas, preventing the radiation from pushing it back. Imagine a jet of water being forced through a pipe. Even if there is pressure pushing back, the pipe keeps the water moving forward. If magnetic fields are acting like these pipes, it would allow the black hole to force-feed itself at a much higher rate. It adds a whole new layer of complexity to these objects, turning them from simple holes in space into sophisticated cosmic machines. Another fascinating possibility is that we are witnessing a black hole merger. If two large black holes collided and became one, their combined mass would jump instantly. If this happened multiple times, you could get a supermassive black hole much faster than by just eating. However, the light from LED 20488 looks like it's coming from a single, steady source of accretion, not a chaotic post-merger mess. Also, for mergers to happen that early and that often, the universe would have to be much more crowded with black holes than even our current busy models suggest. Every answer we find seems to open up three new questions. We are in a revolutionary phase of astronomy, where the more we see, the less we know for certain. What does this mean for the future of our own galaxy? The Milky Way has a supermassive black hole at its center called Sagittarius A*. Fortunately, our black hole is a very quiet sleeper. It isn't growing much at all, but LID 20488 shows us what the youth of a galaxy looks like. It tells us that our own galaxy's heart was once a raging, hyper-growing fire that could have destroyed everything in its path. By studying these distant monsters, we are essentially looking into our own ancestry. We are seeing the Big Bang era through the lens of a black hole that refuses to follow the rules. It makes us appreciate the stability of our current cosmic afternoon even more. The no scientific explanation part of this discovery is what gets people excited. In science, no explanation is the start of a great story. It means we've reached the edge of the map. It's an invitation for the next generation of physicists to find a new way to describe the universe. Maybe the Eddington limit isn't a law but a suggestion? Maybe there is a property of light we haven't discovered yet that allows it to pass through matter more easily in certain conditions? Or maybe the early universe was filled with primordial black holes. Tiny black holes formed in the Big Bang itself that acted as Lego bricks to build the giants we see today. The mystery of LID 20488 is a catalyst for new thinking. NASA's announcement isn't just a technical update. It's a profound reminder of the universe's capacity to surprise us. We built the James Webb Telescope with specific goals in mind, to see the first stars and to find water on other planets. But the best part of any mission is the unknown unknowns. The things you didn't even know you should be looking for. Finding a black hole that grows 7 times faster than physics allows is the ultimate unknown unknown. It's a gift from the cosmos that says, you think you're smart? Try to figure this out. Let's think about the density of the gas around LED 20488. For a black hole to eat that much, it must be surrounded by a massive, endless supply of fuel. This suggests that in the early universe, gas was not yet organized into stars and planets. It was a raw, primal soup. This black hole was like a whirlpool in a vast ocean of energy. The speed of its growth is a reflection of the density of the environment. If we can understand why the gas was so ready to be consumed, we can understand how the first structures of the universe were built. Was the gas pushed into the black hole by the radiation of nearby stars? The Hubble Space Telescope gave us the deep field. Thousands of galaxies in a tiny patch of sky. James Webb is giving us the deep history, the actual timeline of how those galaxies were built. LID 20488 is a star player in this new history. It's a record of an era of hyper-evolution. If things can grow 7 times faster than we thought, then the age of the universe might be more meaningful than we expected. It's not just about how many billions of years have passed, but about how much action can be packed into a single million-year window. We are moving from a static universe to a dynamic universe, where things can change in the blink of a cosmic eye. Another angle the researchers are looking at is energy leakage. Is it possible that the black hole is hiding its energy? Perhaps it's emitting jets of matter that we can't see from our specific angle? If the black hole is pushing its energy out in narrow beams like a lighthouse, then the light pressure wouldn't be pushing against the falling gas in other directions. This would allow the black hole to swallow from the sides while screaming from the top. This beaming effect is seen in objects called blazars, but LID 20488 seems to be glowing from its entire accretion disk. This makes the beaming theory a bit harder to prove, but it's another exciting possibility. Could this lead to new ways of understanding energy here on Earth? Of course, we aren't building black holes in labs, but the physics of how radiation interacts with matter under extreme pressure is the same physics used in fusion energy research. By understanding how LED 20488 bypasses the Eddington limit, we might discover new properties of plasmas and light that could have applications we can't even imagine. Space exploration always pays dividends in ways we don't expect. The impossible black hole might hold the key to a more possible energy future. The search for more objects like LED 20488 is now a top priority for the James Webb mission. If we find more of them, then LEED 20488 isn't a freak, it's a standard. If it's a standard, then our entire model of black hole growth in the early universe has to be scrapped and rebuilt from the ground up. We are looking at a potential Copernican moment where we realize we weren't looking at the universe correctly. It's a thrilling time to be an astronomer. Every new image from Webb is like a piece of a puzzle that is suddenly making the old picture look wrong. Think about the event horizon, the point of no return. For LID 20488, the event horizon is growing at a rate of kilometers per second. It is literally claiming a larger and larger piece of the universe for itself every single moment. The boundary of the unknowable is expanding. This black hole is a growing shadow in the middle of a blazing light. It is one of the most extreme environments in the history of existence, and we have a front-row seat to the show. As NASA continues to track the X-ray emissions from this region, they are looking for flickering. The way a black hole's light flickers can tell us about its size and how cleanly it's eating. If LID 20488 flickers in a certain way, it might reveal that it's actually pulsing, eating a lot, then stopping, then eating again. This pulsed accretion could be a way to temporarily bypass the Eddington limit. Imagine holding your breath to run through a fire. You can't do it forever, but you can do it in short bursts. If the black hole is doing this millions of times a year, the average growth would look like it's 7 times too fast even if each individual swallow was within the limits. Whatever the answer turns out to be, whether it's new physics, magnetic harnessing, or jumbo seeds, the discovery of LED 20488 has already changed the game. It's a reminder that the universe is not a textbook. It tells us that we have so much more to learn about the nature of gravity and light. As we look toward the future of James Webb and the upcoming Nancy Grace Roman Space Telescope, we are going to see even further back. We might even see the Big Bang itself in gravitational waves. In that world of the very beginning, we might find that everything was growing too fast. LID 20488 might just be the first monster we've spotted in a whole room full of them. And that is a beautiful, terrifying thought. The early universe was a place of hypergrowth, where the rules were being written in fire and gravity. Exploring the unexplained is the highest calling of science. When NASA says they found something that has no scientific explanation, they are saying they found something that will lead to a new science. LID 20488 is that something. It's a red-shifted beacon from a time when the universe was young and wild, and it's telling us that we are just at the beginning of our journey of understanding. A hyper-growing black hole is a testament to the fact that there is always more to the story. So, the next time you look at a picture of a black hole, remember LID 20488. Remember that somewhere out there, a monster is breaking the speed limits of the universe and eating 7 times faster than it should. It's a puzzle that has left the world's smartest minds in the dark, and that's exactly why it's so incredible. Space is the ultimate mystery, and black holes are its deepest secrets. The hunt for the why is on. Stay curious, stay amazed, and never stop looking at the darkness, because that's where the most interesting things are happening. We've only just begun to see what's really out there. The universe is much faster, much brighter, and much more mysterious than we ever dreamed. This is the new era of astronomy, and the rules are about to be rewritten. You can bet there are others out there doing the same. Exploration is our destiny, and the unexplained is our playground. Let's find out what's next.